Hello there and welcome to a brand new video. This is Hub Beyond Numbers where we learn maths the easy way. In this video, we are looking at another form of representing vectors, and that is the magnitude bearing form. In our previous video or lesson, we looked at the column or the component form. In this one, we are looking at the magnitude bearing form. Without much I say, let's quickly go into it. So for the magnitude bearing form, this is how it generally looks like or appears. So it looks something like this, where your R, so your R over here is the magnitude of the vector. So that is the magnitude of the vector. And this over here, which we call theta, would be your bearing. That is the bearing or the direction of the vector quantity. So let's look at some examples. Let's say we have vector AB. So AB equals 5 kilometers as your magnitude and your bearing being what? 0.45 degrees. This should tell you that you are moving from A towards B, which is 5 kilometers away from A. And in terms of bearing, it is what? 0.45 degrees away from what? A. So this is how we interpret the magnitude bearing form. This also can be another example. So we have CD, which is what? 2 meters and 275 degrees. So this should tell you that your magnitude should always have a unit, whilst your bearing should always be the true bearing, you see, or it should be a 3-figure bearing. So let's quickly look at how we can represent these vectors on the Cartesian plane, just as we did for the component forms. So talking of representing these magnitude bearing forms in our Cartesian or on our Cartesian plane, there's an example here. It says we have to express VW, which is 4 kilometers 080 degrees graphically. Represent this graphically. So you first need to take note. The unit here is in kilometers. And what you have here is in what? Bearing or degrees. So we come to our Cartesian plane and we write a scale. You see, so over here it says 4 kilometers, right? It says 4 kilometers. So we let our scale be every 1 centimeter will be a kilometer. Every 1 centimeter will be a kilometer. What do you mean by this is every 1 centimeter on your graph sheet will be a kilometer. Every 1 centimeter on your graph sheet is going to be what? A kilometer. So with that said, we'll take a look at our vector, our magnitude bearing representation again. So I'm just going to copy that and paste it here for reference sake, right? So it says 4 kilometers 80 degrees. 4 kilometers 80 degrees, and then it's from it's from vein to W. So our origin here is where our vein is going to be. And always remember, bearing starts from the north. So it means our north is going to be up here, and we measure an 80 degrees. We measure an 80 degree, a bearing of what? 80 degrees. So this is my protractor here, and I'm going to use that to measure my 80 degrees from the north. So this is going to be my north here. And I would measure my 80. So with my inner calibration, that is where I have my 0. You realize that my 80 degrees falls over here. So this here is my 80 degrees. So I have the bearing now, which is the 80 degrees. Then now we come and say it says 4 kilometers. 4 kilometers. So we would have to measure 4 centimeters. You know why we would have to measure 4 centimeters? Because we said every 1 centimeter is equal to 1 kilometer. Every 1 centimeter is equal to what? 1 kilometer. So on what I have drawn, I'm just going to stick to what? 4 centimeters. So this is 0 to 1 to 2 to 3 to 4. So I'm going to clean all the S's. So I'm cleaning all of this, and I'm just going to leave that to what? 4. So with this now, I am done. I have my V, and I'm going to have my W over here. And take note, this point here, S your W. You see, and we indicate its measure. We said its measure was what? 4 kilometers. So you put your 4 kilometers nicely over there. And that is all. This is how we represent the magnitude bearing forms on a Cartesian plane. It is very straightforward. What are the steps? Make sure you know your scale you are working with. If you know your scale you are working with, and with your understanding of bearing, you measure that bearing or the angle. And with respect to your scale, you measure the magnitude that was given in the question. So let's do one last one so we see. Okay, so let's look at this second one here. We have to express AB, which has what? The magnitude bearing from 5 meters, 120 degrees. You have to express it graphically. Take note of your unit over here. So your unit informs you of what you have to do to your scale. So we come up here and then say our scale. For every meter, or for every 1 centimeter, we're using it to represent a meter. You see, so 1 centimeter is to 1 meter. Then we come back and say we have an angle of what? 120. So that is what we need to measure first of all. So I'll take my protractor and measure angle 120 degrees. For mine, my 0 is in the inner, starting from the north. Yours might be from the outer. Anyway it is, just make sure you draw whatever is expected of you. So we are drawing 120. This here is my 120. Let me use a white. So this here is going to be my 120. You see? So after this drawing, I can now take off my protractor. But take note, it says its measure is supposed to be what? 5 meters. 5 meters. And we have said that 1 centimeter is to how many meters? 1 meter. So it simply means we need a 5 centimeter over here. So I'll just put my ruler on my line and measure 5 centimeters. It's so nice. This line here is actually already 5 centimeters, but it just exceeds with a bit. So I'll clean that. So I get my 5 centimeters exactly. And take note once again, it says it is from A to B. So our initial point is going to be what? A here, and then our end point or the terminal is going to be the B here. Not forgetting how much angle we have measured. That is 120. So I put my 120 all the way here. And I write its magnitude. Its magnitude is 5 what? Meters. And that is all. So basically, this is how we represent the magnitude bearing form in or on a Cartesian plane. I've written some questions you can try your hands on to test your understanding. So here are some questions you can try on your own. You are just to express the following graphically. EF, that is 2 kilometers, 270 in bearings or degrees. Then JH, that is 7 meters, 300 degrees. And then IJ, 1 kilometers, 180 degrees. Take note of where these angles are supposed to be, your scales, and the measurement of the magnitude as well. So that brings us to the end of this video. Let's have Beyond Numbers, where we learn maths the easy way. In this video, we've just spoken about how to represent the magnitude bearing vectors graphically. I do hope it helps. Stay blessed. Then see you in my next video.